right, so on page 1 of your handout, top of the page, we defined what a rational function is. And in a nutshell, a rational function f of x is a quotient with a polynomial in the numerator and a polynomial in the denominator. Okay? That's what it is in a nutshell. The ratio of two polynomials. So in the exercise, you're given the rational function f of x is equal to 3 minus x over x squared minus 4. And you're instructed to find the domain and the x and y intercepts, the graph of this rational function. Okay. Well, the domain is straightforward. This could have been an exam 2 question, right? To find the domain, you set the denominator not equal to 0 and solve for x, right? So we have x squared minus 4 can't equal 0, okay? And there are, just to remind you, there are 2 ways to solve for x. First, you can factor the left-hand side into x minus 2 times x plus 2, okay? All right, you should recognize this is a difference of squares, x squared minus 2 squared. And so it factors into x minus 2 times x plus 2. So we have x minus 2 can't equal 0. And we have x plus 2 can't equal 0. And so the domain is x can't equal 2 and x can't equal minus 2, right? So in interval notation, okay? Now it doesn't say to write the domain in interval notation, but we always do, okay? The domain is minus infinity to minus 2, union minus 2 to 2, union 2 to infinity. So that's the domain in interval notation. Okay. Now to find the y-intercept, remember the strategy for finding the y-intercept is set x equal to 0 and solve for y. Well, y and f of x are interchangeable, right? You know, y is equal to f of x. So we set x equal to 0. Now solve for y. Well, what's f of 0? F of 0 is equal to 3 minus 0 over 0 squared minus 4. And when you simplify that, you get y is equal to minus 3/4, or the point 0 minus 3/4 coordinate point. Cool beans? Now, to find the x-intercepts, remember you set y equal to 0 and you solve for x. So when we set y equal to 0, right? Remember y is equal to f of x. When we set y equal to 0, we have 0 is equal to f of x, or f of x is equal to 0. Okay. Well, what's f of x? It's 3 minus x. I'll do it over here. What's f of x? It's 3 minus x over x squared minus 4. Okay. So you just replace f of x here and find the x-intercept. You just replace f of x here with 0. Right? And now you're going to solve for x. Switch two sides of the equation if you want. Okay. Now, we know there are no common factors in the numerator and denominator because the denominator factors in x minus 2 times x plus 2. And so in finding the x-intercepts, what you end up doing is just setting the numerator equal to 0 and solve for x. But we're going to prove that. So since there are no common factors in the numerator and denominator, we multiply both sides by x squared minus 4. And we have x squared minus 4 times 3 minus x over x squared minus 4 is equal to 0 times x squared minus 4. And so by multiplying both sides by x squared minus 4, okay, the x squared minus 4's cancel, and we're left with 3 minus x on the left, and 0 times x squared minus 4 is just 0. And so we just ended up taking the numerator 3 minus x and setting it equal to 0 to find the x-intercept. And when you solve for x, you get x is equal to 3, or x is equal to the point 3, 0. So the graph of this rational function has one x-intercept. It's at x equals 3, or the point 3, 0. And just to verify, you can see that our function is a rational function, because in the numerator, that's a polynomial of degree 1. In the denominator, that's a polynomial of degree 2. Right? This is a polynomial over a polynomial. Any questions on that, ladies and gentlemen? Okay. So let's take a look at the next one. It's a bit more challenging. We have f of x is equal to, in the numerator we have the third degree polynomial, x cubed plus 2x squared minus x minus 2 over x squared minus x minus 6. Okay. Well, to find the domain, we set the denominator not equal to 0, and then solve for x, right? Well, the denominator factors into x minus 3 times x plus 2. So x minus 3 can't equal 0, and x plus 2 can't equal 0. And so we have x can equal 3, and x can equal minus 2. Okay. So the domain in interval notation, minus infinity to -2 union -2 to 3 union 3 to infinity. Okay. All this should be old hat, right? Math is cumulative, right? So we were doing this way back when, okay? Reviewing this, okay? All right. Now, to find the y-intercept in the graph of this rational function, right? Y is equal to f of x. You set x equal to 0 and solve for y, right? Now, because these are polynomials, right? Polynomial numerator, polynomial denominator. Whenever you put in 0 for x in the numerator, right, the numerator is just going to equal the constant term. And whenever you put 0 in for x in the denominator is just going to equal the constant term in the denominator. So we're going to end up with -2 over -6, which is equal to 1/3. Okay. So f of 0 is equal to 0 cubed plus 2 times 0 squared minus 0 minus 2. In the denominator, we have 0 squared minus 0 minus 6. And so you end up with y is equal to -2 over -6, or y is equal to 1/3. Right? So the y-intercept is at y equals 1/3, or the point 0, 1/3. Cool beans? Okay. Now here's the difficult part. Okay. Before we set to find the x-intercept, I said in the previous example we just had set the numerator equal to 0 and solve for x, right? But we got to find, back in section 1.5, exam 1 material, we were reducing rational expressions like this, canceling out common factors. Before we do that, we got to find out if there are any common factors in the numerator and denominator involving x. Because if there are, right, instead of an x-intercept at that value of x, you know we have a hole in the graph at that value of x. Okay? So we don't want to confuse a hole in the graph with an x-intercept. Okay? So we got to factor the numerator and denominator. We already know what the factors are of the denominator. Okay? Well, the numerator is a third-degree polynomial with integer coefficients. And so one of the zeros of that third-degree polynomial has to be a real number, right? It might be a rational real number, might be an irrational real number, right? So if it's an irrational, or if it's a rational real number, we know how to get the possible rational numbers list, right? You take the integer factors of the constant term -2 and divide them by the integer factors of the leading coefficient +1. And when you do that, right, you end up with 1, -1, 2, and -2 as your possible rational zeros list. Okay? There are only 4 numbers. And so when I worked this problem on my own, I discovered x equals 1 is a 0. And x minus 1 is a factor. So the numerator, this third-degree polynomial, factors into x minus 1. And then you got to do synthetic division, right? Divide the third-degree polynomial by x minus 1 with third-degree You gotta divide this third degree polynomial by x minus 1 with synthetic division, and you get the quotient x squared plus 3x plus 2. And that's over the factors of the denominator we know are x minus 3 times x plus 2. And now that quadratic in the numerator, it factors to x plus 1 times x plus 2. And that's over x minus 3 times x plus 2. So you see that x plus 2 is a common factor in the numerator and denominator, right? And so they can't, as long as the x doesn't equal minus 2, they cancel, and we're left with x minus 1 times x plus 1 over x minus 3. This is what we call reduced form. Okay. So there's a hole in the graph at x equals minus 2. You put minus 2 in for x, you get 0 in the numerator and 0 in the denominator. So there's no x-intercept at x equals minus 2. There's a hole in the graph. Okay? And to find the y-coordinate, and we'll talk about this more in future examples, to find the y-coordinate for that hole in the graph, we put minus 2 in for x here in reduced form to get the y-coordinate. Okay. So now, to find the x-intercepts for the graph of this rational function, now you set the numerator in reduced form equal to 0 and solve for x. So we set the numerator in reduced form equal to 0, and we solve for x. So we get product of two factors, right? So either the first factor is equal to 0, or the second factor is equal to 0. And we solve for x, get x is equal to 1, and x is equal to minus 1. And so the x-intercepts are x equals 1, or the 0.10, or x equals minus 1, or the point minus 10. These are the x-intercepts. Any questions on that, ladies and gentlemen?